Across the world, extreme weather events are affecting the local conditions in a variety of different ways. Some areas are getting drier and hotter, while others are getting wetter, with floods becoming more frequent and more extreme. Deserts are expanding, and once fertile lands, now lacking vegetation, are being blown away, creating new problems that cross national borders. Formal weather records go back 150 years, but climate scientists have an accurate picture of the planet's varying climate stretching back millions of years. Ancient ice cores and certain geological structures contain reliable records of the Earth's past atmospheric composition and temperature. While these records indicate widely varying climates, conditions have never changed as rapidly as they are changing now. Today, these changes are most noticeable at the poles, with once stable ice shelves breaking up and drifting away. Some estimates say that sea ice in the northern polar region will have completely disappeared within a decade. This iceberg was part of a group seen floating in shipping lanes near New Zealand. Icebergs had never been seen in these waters before, and with the biggest almost 2 kilometres in length, the group of icebergs was creating a significant new problem for shipping in the area. The polar regions have been experiencing above average temperatures for decades. The Antarctic Peninsula has warmed at 5 times the global average, and the Larsen B ice shelf disintegrated between March 1998 and March 1999. Antarctica holds 70% of the world's fresh water, but outlet glaciers, like the Pine Island Glacier, have been receding by around 1 kilometre per year. 244 glaciers on the peninsula have retreated by around 600 metres since 1953. Lonnie Dupre and Eric Larsen have seen the ice cap surrounding the North Pole at close range, and the thinning ice put their attempt to cross the ice cap during summer in great danger. Conditions meant that dogs and sleds could not be used, so the experienced polar explorers dragged canoes instead. The pair set off from Canada in May 2005, attempting to cross the Arctic Circle to see just how much of the polar ice cap was melting. The journey was far more perilous than the explorers had envisioned, and after 23 days, they had to call in a helicopter to rescue them. The ice is breaking up earlier in the season and refreezing later. In Greenland, the vast ice sheet is melting too. The extra amounts of liquid water are having an effect on the glaciers, acting as a lubricant. Some large glaciers here have been recorded moving as much as 10 metres in a minute. Such movements are not smooth, and the jolts are registering as seismic activity. Computer projections say that by the end of this century, Arctic temperatures will be 4 degrees Celsius warmer than they are today, with substantial parts of Greenland remaining above freezing for many months of the year. This will mean global sea levels 1 metre higher than they are at present, so changes happening in the far north and far south of our planet will have worldwide consequences. But it's not just polar glaciers that are diminishing. In Argentina, the Perito Moreno Glacier has been attracting tourists as it collapses in midwinter. It was the first winter rupture of the glacier since 1917. Periodically, the glacier forms a natural dam across Lake Argentina, forcing water levels to rise by as much as 30 metres before the ice wall dramatically collapses. It is one of only 3 of the 200 glaciers in Patagonia that is not in retreat. After Antarctica, the Patagonian icefield is the biggest continental ice extension in the world, and, like other areas of ice around the planet, it is showing serious signs of deterioration. Glaciers also occur in tropical regions, but only in the highest mountains. In Venezuela, Mount Bolivar is the country's highest. It has snow all year round, and it also has 3 glaciers, but these are seriously stressed. Venezuela has other glaciers on Mounts Humboldt and Bonpland, but they are also diminishing. The tropical glaciers across the entire Andean mountain range are melting, and that threatens the region's freshwater reserves. The glacier on Peru's Calchea Peak in Cusco is melting at a rate of 60 metres a year. Across the Chilean Andes, the melting is happening at an average rate of 1 metre every year. Beyond 2020, water supplies for major cities like La Paz, Lima and Quito are in doubt. Other places are starting to show signs of changing ocean levels. The Brazilian town of Atafona is being swallowed by the ocean as rising sea levels and changes to currents and wind patterns are eroding the once stable coastline. So far, 183 buildings have been destroyed, and the marine lighthouse has been moved twice in the past 30 years. Researchers from the Federal Fluminense University created the Atafona project in 2003 to study the causes of accelerated coastal erosion in the region. The prevailing winds have become stronger, driving more powerful waves that are changing the shape of the coast. The northeasterly wind blows strongly, and the nearby Paraibo do Sol River flows at a reduced rate. The river used to deposit sand at the coast, which would provide a buffer zone, but with the declining flow, the sand no longer reaches Atafona. The local fishing community has had to abandon homes and rebuild further inland. Climate change is being blamed, but the causes are a mix of global and local factors. The once powerful river has almost 9,000 factories along its course, all taking water. This small island at the mouth of the river used to house 30 families, but today only 8 homes remain. 79-year-old Belita Pedra, the island's oldest resident, has been forced to move 6 times because of erosion. Despite the signs that erosion in the region may be cyclical, researchers are investigating what may happen in the future as temperatures and sea levels continue to rise. Atafona's destiny is uncertain, but the prospects for Pedra and her neighbours are bleak. Atafona is not the only place suffering. Across the world, India's southern Kerala state has been experiencing extreme coastal erosion during the monsoon season. Scores of houses belonging to fishermen living along the beach are destroyed each year due to the erosion. Most will not be rebuilt. Many families unable to rebuild continue to live in damaged houses. Kerala witnesses rough seas and heavy rainfall during the monsoon season between June and August every year. Residents blame ineffective and unscientifically built embankments along the coast as the main cause of the erosion, and they have now started putting bags full of cement near their houses to block the waves and prevent further erosion. There's little doubt that the sea walls could be stronger, but coastal erosion is a problem being faced around the world, a problem that has intensified over the past few decades. A sea level rise of just 1 centimetre does not sound like much, but this small amount means that storm surges will penetrate much further inland, threatening buildings that once lay far beyond the high water mark. No one knows what the projected 1 metre rise by the end of the century will mean. Australia's Great Barrier Reef is the planet's largest system of coral reefs. Despite the fact that it is protected and that it is the focus of a very profitable tourist industry, the reef is under threat. This delicate ecosystem is sensitive to ocean surface temperature, and warm periods are causing bleaching of part of the reef. If the Earth continues to warm at its current rate, half the world's tropical corals will be gone by 2030. Deeper in the oceans, life faces a different problem. Along plate boundaries, volcanic vents heat the waters and provide an unusual mix of nutrients that sustain the only life on the planet that does not rely on the sun for energy. However, even here, life is under threat from higher levels of CO2 that lead to increased acidity. A Across the world, weather patterns are changing. In 2002, Europe, especially Germany and the Czech Republic, suffered what was called a once-in-a-100-year flood. Just 4 years later, the same region suffered what was called a once-in-a-150-year flood. In Mozambique, catastrophic flooding of the Zambezi River hit in 2000, 2001, 2007, and again in 2008. Thousands have lost their lives, and agricultural production has been severely affected. Increasing industrial levels of CO2 are holding warmth in the atmosphere and changing the weather. In the Indian state of Bihar recently, 3 million people were displaced by unusually severe monsoonal rains. Such events set off a chain of subsequent problems, including waterborne diseases and disrupted food supplies. However, for every place with too much water, there is another that does not get enough. The world's deserts are expanding at an alarming rate. The Chinese part of the Gobi Desert is the focus of a massive tree planting project intended to act as a buffer to stop the desert's advance. People living on the margins of the desert are in a constant battle to stop the encroaching sands. The tree planting is a step in the right direction, but the authorities cannot make it rain, and without water, the green areas will wither and die. Nearly 1/5 of China's landmass is affected by desertification. A persistent drought in the northern parts of China has only added to the problem. The government is testing cloud seeding techniques with limited success, but the real problem is global and will need an international solution. Since 2005, farmers in northern China's Hebei province have been encouraged to plant trees twice a year to slow the rate at which desertification is eating up arable land. Sandstorms plague the country every spring, reaching as far away as South Korea and Japan, turning rain and snow yellow. Scientists estimate that 250 million people worldwide are directly affected by encroaching deserts, warning that desertification is threatening 1/3 of the Earth's land surface and could lead to famine and drought. China is able to marshal vast human resources to replant barren areas, but the world's growing population is a major part of the climate change problem. More people need more raw materials and have a greater impact on our finite world. Overgrazing and overfarming are as much an issue in most areas suffering from growing deserts as climate change, but the two issues are related. Other productive areas are experiencing unprecedented drought, and productive agricultural land is lying barren waiting for rain. A report from the Climate Study Group at Britain's Bristol University states the Earth is already committed to an average global temperature increase of 2 degrees. This will mean increased frequency of wildfire, which will in turn add CO2 to the atmosphere. If we are unable to hold the average global temperature increase at less than 3 degrees, the warming effect will gather momentum from the extra CO2 given off through fires and accelerated decomposition of biomass. With higher temperatures, the risk of severe events such as drought, fire, flooding and storms of increasing severity increases exponentially. Currently, severe or exceptional droughts are being experienced in southern Australia, the Middle East, southeastern Europe, Central Asia, Argentina, and the northwestern regions of North America. In all these areas, fire risk is extreme during the summer months. Almost 60 million people around the world are living in conditions of exceptional drought. Though fire is a naturally occurring event, there are some parts of the Amazon rainforest that have started burning, which has previously been unheard of, as tropical forests usually have such high levels of rainfall. The levelling of forests for slash and burn agriculture is adding to the problem, as fire is typically used as the method of clearing. Forests fix huge amounts of atmospheric carbon, and the loss of vast tracts of tropical forests due to increasing human population pressure contributes to the increase of greenhouse gases in the air. Eucalypt forests across drought-stricken southern Australia are particularly vulnerable, and local fire authorities are trying to reduce the risks by controlled burns during moderate weather. More areas are becoming prone to wildfire, and governments are having to devote more resources to managing the risk of fire. As weather patterns change, fire is being fostered by extremes in both temperature and wind. The symptoms of changing global climate are becoming obvious, but climate scientists are using very sophisticated methods to understand what conditions have been like in the distant past and what we can expect in the future. Again, the polar regions hold clues to exactly how our planet is changing, and research stations have been set up on the very thick ice sheets to examine the climate record of almost 1 million years frozen in the ice. The EPICA project includes scientists from 10 European countries working together at an Antarctic site called Dome C, where the ice is more than 3 kilometres thick. A drill site situated in an artificial cave beneath the ice ensures that samples gathered from deep below the surface stay frozen. Any thaw in the samples greatly reduces the quality of information held within the cores. Small bubbles trapped in the core samples are specimens of air from the ancient atmosphere. Analysis reveals a detailed record of the composition of the atmosphere year by year for the past 800,000 years. In addition, the ice cores give an indication of past temperatures. Because water contains isotopes that vary in weight, which condense at different rates according to temperature, the core samples hold a reliable record of past temperature. At shallow levels, the yearly delineations in the ice are easily seen, either by eye or by analysis. But at greater depths, the weight compresses the ice, and different years must be determined by more technical means. A history of the world's technical developments is also extant in the ice record. Traces of various complex man-made chemicals are not present in samples dated beyond 1880, but the signs of smelting of metals stretch back to the beginning of the Bronze Age. Samples are carefully labelled and packed for transport back to laboratories in Europe. The technique is also being used to analyse ice from glaciers. In Argentina's Patagonia, the core sampling technique is being used on the ancient analyses trees growing on the shores of Lake Nahel Huapi. The trees are amongst the world's oldest living things, surviving as long as 2,000 years and growing to a height of around 50 metres. International researchers regularly make the journey to Patagonia to study the analyses. They too hold clues about past temperatures and have provided new information about the ancient climate. Like all trees, analyses form a new layer of wood under their bark every year. So samples of the trees taken straight through the core allow researchers to gauge what the weather was like in each year of the tree's life. The tree rings show that the temperatures during the 20th century were anomalously warm across the southern Andes. At their worst, mean temperatures over the last century went up 0.86 of a degree Celsius when compared to temperatures over the previous 260 years. The team know that Patagonia's hottest year in the past 400 years was 1998. This accuracy extends weather records back for centuries before the formal register was established in the mid-19th century. Because this wood is highly resistant to decay, buried trees can extend this reliable climate record back as far as 5,000 years. Modern urban life depends on energy, most of which is generated by the burning of fossil fuels, liberating carbon that was fixed by plants millions of years ago. pre-industrial levels of CO2 in the atmosphere were between 260 and 270 parts per million. Today, there are slightly more than 380 parts per million. Carbon dioxide is a better insulator than the other major atmospheric components, so the atmosphere is holding in more of the heat radiated to the Earth by the Sun. This extra heat is altering the planet's weather patterns, with drastic effects on animal life adapted for specific conditions. One animal under great pressure from changing climate is the polar bear, as its icy environment is changing more rapidly than temperate regions. Other creatures that live in the frigid zone are also being affected, and zoologists are trying to monitor the complex changes that are unfolding. Less polar ice means less algae at the bottom of the food chain, and in turn less krill, as well as the larger and larger animals in the complex web of life. Expeditions to the dwindling northern polar region are using new techniques just to learn what creatures live in the frigid zones. It is feared that animals living there will become extinct before anybody knows they exist. This is a newly discovered species of serrate octopod. This environment is very delicate, and yet we have no formal method of placing value on things that do not generate human wealth. But there are other animals that are being badly harmed simply by getting in the way. Each year, more than 300,000 seabirds, including 100,000 albatrosses, are unintended victims of the fishing industry. Long-line fishing techniques use baited hooks on cables that stretch for 80 kilometres. Before they have a chance to sink below the surface, seabirds dive for the bait and become hooked. This is fishing on an industrial scale, and it is extremely profitable. But every piece of bait that is lost to a bird is one less fish that is caught. Yet, so far, new methods designed to keep the birds away have been patchy. The idea that anything that interferes with human economic activity is just collateral damage is starting to change, but is it changing fast enough? The Earth is losing species at an alarming rate. If we cannot learn to value the creatures that evolved alongside us, we will face a bleak future. Our world is changing rapidly, and no one can be certain how things will develop, but humanity does have the ability to protect our planet.